Good day, everyone. You are welcome to today's session. And in today's session, we are going to continue from where we left off on the topic, trig. In the previous meeting, you realized that we had diagrams already provided, and we were supposed to use the diagram, to answer some follow-up questions, under trig. So indirectly, we're looking at application of what trig, basically. But that one, we had diagrams provided, and we're supposed to use all the concepts learned, to deal with what the question that were connected to what the diagrams. In today's meeting, our basic task will be looking at word problem, trying to get the diagram from the word problem, and proceeding from there. So indirectly, we are still on the application of what? Of trig, but this time round, we are dealing with application in the word problem form. As simple as that. So basically, our main goal, is to know how to deal with word problem connecting trig, questions, or trig application words questions to be more specific. All right, so without much ado, let's look at exactly what we have on our screen. Our very first word example and this. So we are told a ladder leans against a vertical wall at an angle of 60 degrees to the wall. If the foot of the ladder is 5 meters away from the wall, we are to calculate the length of the ladder. The length of the ladder. So we are told that the wall is vertical. So you picture the situation. I've told you as you read question, try to think through the question, appreciate what the question is talking about and its demand. All right. So we have a vertical wall and a ladder leaning. So usually if you have a wall and a ladder is leaning against it, then you know that the ladder will be diagonal to the wall. I hope my point is well made.
Yes, please.
So once your ladder is diagonal to the wall, then it means the ladder obviously will make, because the ladder will meet the wall, it will make a certain angle, to the wall or with the wall. So the angle with the wall is what we are given in this word question. So your ladder will make an angle, to the wall and also an angle to the ground. But you can see that here, we are rather giving the angle, to the wall, not the angle to the ground. So when you are getting your diagrams, you have to, make sure you use the exact information provided, in the question. So what do? I am going to, first of all, write solution, then I'm going to draw my vertical wall. So this is my wall. All the information that you are dealing with, you'll be dealing with points and lines, basically. So if it is a vertical wall, you draw a vertical line. If you mention horizontal, whatever, it will be a horizontal line, and points are points. So in this case, I am going to draw my vertical wall. So this is my wall, basically. I'd wanted to pick the and do it, but I can still use my free hand. Still look straight, though crooked. But my point will still be made. And so this is my wall, indirectly my wall. Which is vertical, and my ladder. So the wall, obviously will be on the ground. The ladder, its end, will be on the ground. So this is where you have your ground, and your ground will always be horizontal. So indirectly, I have this to be my ladder. I hope my handwriting is legible.
Manageable.
It's manageable. It's the digital board. So please, if you can't see, just let me know. So your ladder, your vertical wall is vertical, your ground is horizontal, so they will always meet at an angle of what? 90. So this is what we have. So you now have your ladder, your vertical wall. Now let's go and introduce any known angles or any known length. So we are told this angle here is for the angle that your vertical wall makes to what? or the ladder makes way to the wall. So in this case, okay, this is where the angle will be, true or false. Okay, this is where the angle will be. 60 degrees will be here, true or false.
True.
Really?
False.
It will be false. I am so pleased if I ask question, okay, think through well before you answer. If you look, this is the ladder. However, this is not the wall. So the information here is about the angle between the ladder and the wall. So if you put your 60 here, then it means your picture that you have here is not exactly what is indicated in this situation. Okay, so this is your wall, this is your ladder. So it means it is rather this angle that must be 60 degrees. Do you agree, my professors? Especially those of you who thought it was yes. All right. So I come and indicate my 60 degrees here. Okay, so this is my 60 degrees angle. And I'm also told that if the foot of the ladder is 5 meters away from the wall, so this is the foot of the ladder. Okay, and this is the wall. Okay, so if you are talking about what the wall, 8 foot indirectly will also be here. So we are rather talking about this distance being what? Because this is the distance the foot, okay, of the ladder is from what? The wall. So this is the distance that we are told is 5 meters. So we come and indicate 5m here. All correct, my professors?
Yes, sir.
Okay, so it seems someone. Okay, so I was reading somebody's thesis. Okay, this one, yeah, we need time to read it. So maybe during break, us. Okay, I'll read your thesis. Okay. If I start reading now, by the time I finish, maybe the class will end. Okay. Okay, so let's go there. Let's continue from where we left off. Okay. All right. So in this case, this is the figure that we have before us. Okay, so we've exhausted all the information provided in the question, in terms of the diagram. So now what do we do? What is the question asking us to find? We are supposed to calculate the length of the ladder. So we are supposed to find this, length. Okay, so on that note, for better presentation, we are going to indicate where you have the lines meeting, by points. So in this case, I will call this maybe point A, point B, then point C. You can label it anywhere, only that you cannot use small letters. Points are always indicated by small letters. However, you can use, any letter that you want. Okay, so in this case, this is what we are going to do. Okay, so let's see. If I have a right angle triangle, I know one side, I know an angle. I thank God. Once I know an angle, and one side of any right angle triangle, any angle that is left, I can find it. Any side that is left, I can find it. And here, the question is asking us to find the side, which is the ladder, and that is the hypotenuse. Do you all agree?
Yes, sir.
Okay, so
Yes, sir.
once you know that this is the hypotenuse and you are looking for the hypotenuse, the question has given you, the length of the opposite, because now that's where your angle is. So each opposite length, or side will be this side, which is of length 5 meters. So I know opposite and I'm looking for the hypotenuse. Okay, so which trig ratio should come to mind?
Yeah.
Hello, which trig ratio, my professors?
Tangent.
Tangent, opposite, hypotenuse.
Sine.
Okay, so please take note. So it is what? So, ka, toi. Okay, so opposite hypotenuse, is in, so which involves sine. So it means we are going to deal with what? The sine. So in this case, I'll write, sine, which angle? 60 degrees. Will be equal to, I know sine is what? You said opposite over hypotenuse. So opposite is 5, ignore the unit. Over the hypotenuse, which is what? Your 5, hypotenuse is AC. So the length of AC. All correct, my professors? Are you all following? Is everyone following?
Yes, please.
Okay, very good. Okay, so now at this point, I'm looking for AC. I wouldn't, tell you to use your calculator to find this value. Okay, hold on with this, although its value will be pretty. Okay, if it is pretty and you immediately feed your calculator and gives you a pretty value, meaning a definite fraction that you wouldn't approximate, a definite value, okay, an integer value, okay, you can put it there. Okay, but if it is decimal, don't go and put it. Other than that, you do more, okay, rounding offs, which will move you away from your accurate answer. So for me, this is what I advise students to do. Because this is a relation, I'll come and write. This implies that, okay, I'm looking for AC, so I cross multiply. So that will give me the length of AC, okay, sine 60 degrees, okay, will be equal to 5. Do you all agree?
Yes.
Okay, and please take notes. Don't write sine 60 degrees AC. Always, you know, AC will be a constant. So you always write a constant before your trig ratio. So take notes. Okay, so what do? You write it again before you divide. So by so doing, you are going to get AC, the length of AC, okay, to be equal to 5 over sine 60 degrees. Do you agree?
Yes.
Okay, so my sine 60 is not, okay, looking well. Okay, I've even, so please let me correct that. Okay, so that at least it will be a little legible. Okay, so this is what we have. Oh, where from this? Okay, there shouldn't be any brackets there. Forgive me. So what was I thinking? All right. Okay, so this is what we have. So now we come and what? And continue. Okay, so if you continue, this is what we are going to get. We are going to get our AC. So now you can use your calculator. So your AC that you have there will be equal to. So use your calculator to do 5 over sine 60 degrees. That one you approximate only once. My professors, are you there?
Yes, sir.
Okay, all right. So I need your calculator values.
5.8 meters.
5.8
meters.
Okay, so please take notes. Okay, I said your first approximation must be how many DPs?
The 4 DP.
4 DP before any other, okay, DPs. As for 1 DP, 2 DP, at least 3 DPs, but we always go for 4 DP. So give me the 4 DP approximation.
5.7735.
5.7735.
35.
I hope you check the next digit.
Yes, please.
Okay, so 35. Okay, you've approximated, it has a unit. Okay, it's length, meters. And anytime you approximate, don't forget to put your approximation in brackets. So this is 4 DP approximation. All correct?
Yes.
Okay. Okay, so at this point, unfortunately, I cannot draw my conclusion with what the AC. I introduce A and introduce C. So in math, you always avoid, okay, concluding with what you introduce. So in that case, I'm going to, okay, use the wording of the question to help me, okay, draw my conclusion. So I'll write therefore, okay, 5.7735 meters is equal to, okay, length of the ladder or ladder length. That will be more concise and precise. Safa.
Yes, sir. Yes, please.
Okay. Any questions, my professors? Okay, great. So it means everyone is on board. Okay, all right. And please take note here. I will take my time and teach you. When you go back to school, it will not be like that. So make sure you take advantage of this, okay, to ask all the necessary and relevant questions. Okay, so now let's move on to our next, okay, question. Okay, so let's picture the situation here as well. A vertical pole 6 meters high casts a shadow, okay, 9 meters long at the same time that a tree cast a shadow 30 meters long. Find the height of the tree. Okay, so here, how many verticals do we have? If you think through the question, how many vertical lines are we going to draw? Two. Do you all agree?
Yes, please.
Okay, one for the pole and one for the tree. I hope you are with me.
Yes, sir.
Okay. Now, if you look at the information that we have there, we are looking at real life situation, all other things being equal. Okay, you can see that the vertical pole, its height is given. Okay, and its shadow is also given. However, the tree, we know only its shadow. We don't know its height, and that's what we are asked to find. So I want to ask this simple question. Now, looking at the information provided, okay, between the tree and the pole, which one do you think is longer or taller? Okay, Prof. Angie.
Sir, please, I'll be leaving the class
Oh,
right now.
okay, so send me a message.
Okay, so send
Are
me
you
a message.
leaving the class permanently or I mean today's class or you
Yes,
come back?
permanently.
This class when you come back?
Permanently.
Okay, so send me a private
Okay,
message.
so
Okay,
send me
by
a
the
private
class and
message.
tell me
Okay,
why.
bye.
Okay,
And tell me why. Okay.
Okay, sir.
all right. Okay, so I was saying that between the tree and what and the pole, which one do you think will be taller? Okay, send me your answers via the chat. Private. Okay, between, so if it is pole, write pole. If it is tree, just write tree. Are you with me? So go to the Zoom chat, not on WhatsApp, please. Okay, send me your answers via the Zoom chat privately. Don't send a general message so that no one gets to see your answers. Okay, and use that to influence his or her response. So I am waiting for some of you. I have quite a number. Okay, so just write tree. Okay, if it is tree, okay, if it is for the pole, just write pole. Okay, so all right, I think so far. Okay, okay, so I've seen variation in the answer, so at least it means it will need further explanation and someone will learn something new. Okay, Prof. Joshua, I don't think you want to answer the question here.
Sir, no, please. It's not about the question.
Uh-huh.
When I started the class, I could not join because I was having some network issues.
Okay, so you are lost.
Yes, sir.
Okay,
Then so
don't worry. Okay, you will bring you back on track.
like it will not be stable. Some 30 minutes or 20 minutes to stop again.
Oh, why? Your network stability
Then,
at your end.
yes, I'm using Telecel. That's why.
Oh, tell us no we throw shades no. All right, okay, so let's see. Okay, great. Okay, so from your submissions, at least, okay, one person said the pole. Okay, and please, those of you who said the tree, okay, what informed that answer? Okay, anyone, you may put up your hand and, okay, let me know. Those of you who said the tree, what informed, okay, I know it wasn't by instinct. Okay, something informed that what, okay, choice. Okay, Prof. Vanessa.
Please, the length of the shadow.
The length of the shadow. Okay, what about the length of the shadow?
Please, if you compare the length of the shadow to the length of the pole, the length of the shadow is longer than that of the pole, and the length of the pole, that means that the length of the tree will be longer or taller than that of the pole.
Perfect. Okay. All right. So, but I thought maybe you summarize it by saying that the longer your shadow, okay, the taller you are. As simple as that. You get the point. But indirectly, that was said anyway. Okay. So please, are you all with me? Do you all agree?
Yes, please.
Okay.
No,
So
please.
Sir,
did,
please,
did, did I hear no?
please, I did not really hear
Yes,
it.
please.
My
I don't
connection
Okay.
is
understand what
So
you are
breaking.
saying.
indirectly, this is what she said. Okay. The taller the length of your, I mean, let's say the taller the length of your shadow, or the more, okay, length you have in terms of your shadow, the taller you are. Do you get it now? So you can see that here, we don't know the height of what? Of the pole and the tree to compare. But we have, okay, information about the shadows that we can use to compare and draw that same conclusion. Okay, so if you are taller, your shadow will be more, I mean, will be longer. Okay, as simple as that. Prof. Caroline, point well made. Or
Mr. Akman, please, you just said that the taller you are, the longer your
longer your
shadow.
shadow.
But it could be that I think it matters. It depends on how far the source of light is, because you could be really short and you stand at some point of like the source of light, then you can see that your shadow is really really tall. So I don't think.
Okay, so this
Yeah.
is it. Okay, so let's see. That same point that you are, if you are comparing, all other things must be equal. So where you are standing and you are taking your shadow, okay, measuring your shadow, that's where the person must also stand. I hope you get my point.
Yes, please.
So we won't say that, irrespective of what you say. If I'm talking about my shadow, so if let's say I'm here, let me, okay, use this. If, okay, this is the object, okay, and obviously the shadow will be on the ground, is that not it?
Yes, please.
Okay, so if my, whatever, the sun rays, what have you, I have the sun here, okay, my source of light is on this side, and the shadow will be here on this side. Do you agree?
Yes,
All
please.
being equal. Okay, now you should know, if the same person will come and say, you go, this is the length of your shadow, it will be taken from your foot up to where this is where your head will be. Do you agree?
Yes, please.
So this here will come here. Your head, which is here, will now be on the ground, okay, at this side. So this will be the length of the shadow. So if you stand the same way and you stand, okay, if you are short, obviously you know your shadow, if you are short, will never be longer than this. If you like, go and try with the same source of light, okay, at the same point. Do you get the picture now?
Yes.
Because how do you measure the length of your shadow? It will always be from your foot, okay, to the head. Okay, all right. So once you get this, then it means, okay, we are in a pole position, okay, to proceed. All right. So on this note, this is the picture that we are looking at whenever you have this situation. Okay, so without wasting, okay, or yes, using more time, I should, okay, do this. So I have two, okay, verticals, a pole and what, and a tree. Okay, so obviously, okay, so I'm going to my tree will be longer. So I'm writing I'm indicating my tree as my vertical, longer vertical line here. Oops. Okay, and so that will be on the ground. And my pole will also be on the ground. So that will be short. Okay, obviously they will not be at the same point. Okay, so they will not all be measured at the same point. In any case, you know where this is grounded. This cannot go and be grounded at the same time. So no matter what, there will be separation. There will be a distance between them. All correct.
Yes, please.
Okay, so this is what we have. Okay, so now when you have this, this is what you do. Okay, because indirectly you are taking your light source here, or your source of light, okay, from this side. Okay, it means your shadow is going to be on this side. Okay, and the shadow you have, okay, this is not your shadow. Okay, if you draw a diagonal line from the top of the tree, okay, so it will just, I think this one I had it drawn Okay, but I can clear this. Okay, so I want you to picture the exact situation. So let me clear this. I think I've buttressed my point very well using, okay, that information that we have here. So quickly, let me clear this. Okay, or let me even, yes, I'm going to reduce the height so that I won't cover more area for me to have. Okay, so this is my pole indirectly. So this is my pole, okay, which will be on the ground, the same ground. So, okay, I will draw a diagonal line from the top here. It will always come and touch the top of what's the pole. Okay, and it will come and end on the ground. Okay, so your ground horizontal level will be this. Okay, so please picture the situation. After that, if you have any question, we'll, okay, look at it. So this is indirectly my pole. Okay, this is my, what do you call it? My tree. Okay, and vertical and horizontals will always meet at an angle of 90. Okay, so this is what I have. I know, look at the question. It said the shadow of what? Of the pole is 9 meters. So the shadow of the pole will run from here to, oops, okay, to this side. Do you agree?
Yes, sir.
Okay, so on that note, I can say that, okay, from here to here will be what? The 9 meters that is indicated there. All correct?
Yes. Yes, sir.
Yes, please.
Okay. Okay, so now let's see. You can see there is also another distance here. Okay, we know the height of the pole. So the pole is what, 6 meters. So let me indicate that. I'm indicating the length that we have in the question. So it's left with the 30 meters. The 30 meters we are told is what? The shadow of the tree. Is that not it? Okay,
Yes, sir.
so the tree-ish shadow will start from its foot, up to the end point here. So it means it is this distance that we've been given there from here to here that we are told is 30. So from here to here, will be 30 meters. So 30 meters. All correct, my professors.
Yes,
Yes,
please.
sir.
Yes,
Okay,
please.
any questions at this point before I proceed? Okay, Prof. Gideon.
So please, I thought the 30 meters to rather be the distance from the ground to the actual tree.
Come again.
So please, I thought the 30 meters would be the distance on ground, the distance on the ground.
Yeah, so this is the ground. You can see that the horizontal here is for the ground, and the ground is where you have your shadow.
Okay, sir, please, thank you.
You get it now?
Yes, sir. Thank
Okay,
you.
all right. Okay, so are we all fine here? Okay, Prof. Frank.
Yes, sir.
Please, the shadow cast from the pole, is it from the shadow of the tree or I mean is it from the tree?
Okay, which distance are you talking about?
The 9 meters.
The 9 meters. So that's why I said, okay, before I even came to draw this, I said that if you are measuring your shadow obviously will start from your foot. I hope you are with me.
Yes,
Have you
sir.
observed your shadow?
Yes, please.
If you observe your shadow, you know that your shadow always will start from what? Your foot or your feet. Okay, then move ahead, of you or go beyond, your foot or feet. So in that case, it means if I'm looking at the pole, a shadow will start from here and end here. And always once your light source is here and you stand at different position, where your shadow will end, that's where, the tree shadow will also end. Another person who stands behind you, a shadow will end. If you like, try. Okay, if you have any siblings, okay, try that. Okay, so they will all end at the same point. So the shadow of the tree will end here, the shadow of the pole will end here as well, once they are facing the same direction of your source of light. All other things being equal. Okay, do you get my point?
Yes, sir.
Yes, sir.
Okay, so Prof. Josephine, your hand is up.
Please, so why is it that the shadow of the tree didn't end at where the pool is, but ended at the far end?
Okay, so that's what then it means you didn't listen attentively. I said, okay, where the shadow of what the tree ends, that's where the shadow of the pole will also end. So they will all end at the same point. So if the tree, its shadow ends here, and the pole, its shadow ends here, are the shadows ending at the same point?
Yes, please.
Oh, let's see. If the tree, this is the tree. If its shadow ends here, okay, and the pole, its shadow ends here. Okay, where the two shadows, okay, you are saying this one ends here, this one ends here. Okay, where they are ending, are they the same?
No, please.
No. So that's why I said where they all have the same ending in terms of their shadows. So the shadow of this tree, okay, will not end here, but rather end at where the shadow of the pole equally ends. So that's the more reason why the distance, okay, for the shadow of the tree, start from the foot of the tree to the end point here as well. But not here. It's not here. That is the 3 meters. Sorry, 30 meters. Point well made.
Yes, please. Thank you.
Okay, very good. So ask all your questions, clear all doubts. So let's look at, so usually if you like, check the recent, okay, WASI. Questions are now moving, I mean, trade question, application questions. Okay, questions are now being application questions. So you need to get the concept clear before. And if you get the diagram wrong, okay, you don't need a rocket scientist to tell you that everything that you are going to do will be wrong. So that's why if you are spending time, okay, to understand the picture before as the diagram, okay, is key. Okay, it's merited. So now what do we do? Okay, so once we have the true picture, remember, okay, for better appreciation in terms of presentation, label all vertices anywhere lines meet. So I'm going to call this A, okay, B, okay, C, okay, then D, okay, E. All correct. Oops, okay, my E is not okay, but in any case, once you can hear, oops, what happened? Okay, let me see. I can still deal with it, no problem. Okay, I hope you are all with me, my professors.
Yes, sir.
Okay, so I'm labeling this point as my E. Okay, take note of that. Okay, so now, okay, if you look at, especially those who watched the video, those who couldn't join us the last vacation classes, but watch the video, you can see that, okay, in that particular video, we had diagrams like this that we had to use to answer some follow-up questions. Okay, so all the diagrams that we've dealt with, okay, any word problem that comes with what trig, okay, will be one of those diagrams. So that's why I spend time for us to know how to deal with those diagrams, so that when you come here, you bring out the diagram, you know, okay, its nature and how to deal with it. Point well made, my professors.
Yes, please.
Okay, so now we know the situation at hand. What are we looking for? We are looking for AB, which is the height of the tree. All correct?
Yes, please.
Okay, so if you remember in that particular lesson, okay, I said there are 2 ways of dealing with this question. Okay, one, using trig ratio or trig complete, okay, Lee. Okay, or using trig entirely to deal with it. Or, okay, in that class, I remember one person asked whether we can use scale factor, okay, situation also. And I said no. Okay, I said yes, but we don't call it scale factor, okay, but we rather call it what enlargement and similar figures, okay, approach. So you can use that one as well. But because by then you have not been taught, okay, I didn't use that, I used trig because we are dealing with trig. Okay, so that one was equally explained in that word video. I stand to be corrected though, but I believe usually I will do that. So what I do, what you are supposed to do at this point, okay, remember, you are supposed to, or you are required to break the composite diagram that we have here, okay, down into a simple, okay, diagram. So you extract the maximum number of right angle triangles that could be extracted as well, okay, from what we have there. So now I know how many right angle triangle can we get from that composite figure? How many right angle triangles?
Two.
Two. Please, do you all agree?
Yes.
Yes.
Okay, so if that's the case, then now I am going to draw. Remember, I said break it down and use it to do your analysis, usually better. Okay, some students, as you mature, you can use, okay, the diagram here completely without breaking it down. Okay, so I am assuming we are not matured yet, and I'm encouraging you to do this to protect our marks. Okay, so my right angle triangles, two of them. Okay, so the first one is the bigger one, which is ABC. Do you agree? Okay, and the next one is DEC. All correct, my professors.
Yes, please.
Okay, so now let's attach the measures. If you come to the ABC, okay, you know BC to be 30. Ignore the units for now. I hope you are with me. Do you know any other length?
No, please.
No. Okay, now let's come to DEC. DEC, you know the distance DE, and that is 6. We also know the distance what EC, that is 9. All correct?
Yes, please.
Okay, great. Okay, so now with this, we are more than good to go. Okay, so let's see. Remember, I said anytime you break down your figures, your composite figure into the simple ones, okay, ask yourself, do you have a common side or a common angle? If you have a common side, then it will be required of you. It will be convenient, okay, for you to form an equation based on the common side and use it. Okay, after you have analyzed the simple figures that we have here individually to see if you can work on it, okay, and get any known side or any known angle. Okay, otherwise you will get, okay, a common angle. So if you get a common angle, you have to form an equation based on the common angle. So if you look at these two simple figures, the size that we have here will be, okay, this one will be AB, so let me write it here. So this one, the side will be AB, okay, AC, then BC. Do you agree? If you come to the second one, the side that you have there will be DE, okay, DC, and CE. I hope you are with me.
Yes, sir.
Do you have any side here that is common here? That is also here?
No, please.
No. So it means you don't have a common side. So once you don't have a common side, then the other one kicks in. Let me go and check whether I have a common angle. Okay, so let's see. In this triangle, okay, the angle at A, obviously I can't say that is the same as the angle at D. Okay, but if you profile that, you know that they will be the same anyway. Okay, so that was just by the way, because you know this will be a transversal. Okay, so these two verticals will be parallel. Okay, and this will be a transversal. So the angle here and the angle here will correspond. So they will be the same. You get the point?
Yes, sir.
Okay, but this is it. The obvious angle that you can see, okay, will be the same, will be the C. Because you can see that, okay, ABC, okay, this one, the angle is at C. DEC, the angle is at C. So the obvious common angle will be the angle at C, and I'm representing that by theta. Okay, theta. All correct, my professors?
Yes, please.
So we all agree that we have a common angle at C from our two simple figures. Afa,
So please, can you go over it again?
I should go over it again. Great. Okay.
Yes.
Okay. So as you understand how the triangles were extracted, right?
Yes, please.
Okay. So I'm saying that if you look at this triangle, the bigger triangle that we have here. Okay, ABC. Look at it. Okay, so let me call this angle theta. The angle here, theta. Okay, so if this angle is theta, if I extract the bigger triangle, okay, will this angle still remain theta? It will still remain theta, right?
Yes, please.
Okay, if I extract the small triangle that I have here, this angle, wouldn't it still remain theta?
It will.
So yeah, I guess that you get it now.
Yes, please.
So the angles are the same. Do you agree? And I was trying to explain that the third angle obviously will be the same. Because if I have a triangle and two of the angles are the same, I don't need a rocket scientist to tell me that the third angle will be the same. You get it? Do you get the logic?
Yes.
Okay, very, very good. Okay, so now, okay, let's go and, okay, now that you've understood, let's go and look at how best we are supposed to, okay, deal with what we have here. Great. Okay, all right. So now let's see. Okay, I have, if I look at this triangle, so let's see. You have to plan and see the execution of your plan. So in this triangle, I know two of the sides. I can find DC. If I find DC, will DC be useful anywhere here? Will it be useful? It will not be useful here. Okay, if maybe you found a side here that is also here, you can come and put it here and use it to find the side AB that you are looking for. I hope my point is well made. So though this triangle has more material to work on, finding, okay, using those materials to find DC will not be that useful. So my point is, once I know that I have a common angle, I am going to form an equation based on the common angle. Okay, so in this triangle, okay, I know the opposite and I know what the adjacent. In this triangle, I know the adjacent, I'm looking for the opposite. Is my point well made? Hello, is my point well made?
Yes, please.
So I am going to form an equation each based on, okay, the triangles. So I'm going to start with this triangle. The order doesn't really matter though. Okay, but because this one has more material to work on, I will start with this one. So can I say that from, okay, once I have two different triangles, you always have to let us know which one you are working on. So from right angle triangle, okay, D, E, okay, C. I can say that tan of my angle theta, okay, will be equal to, tan is opposite over adjacent, so that will be 6/9. Do you agree, my professors? Should I come again or my point is well made? Is everyone fine?
Yes,
Please
come
come
again.
again.
Okay, so possible.
Sir, please come again.
Okay, all right. So, but possible you were with us when we did a trig.
Sir, please, yes.
Hey, you need to revise. So you should have been part of those who, okay, watched the video. Okay, anyway, so this is it. Okay, this is your angle. So to this angle theta, this is the opposite, this is the adjacent. So in this triangle, with respect to my angle theta, hypotenuse, okay, opposite, okay, adjacent, all correct. So I have to make sure my ratio, okay, my ratio that I have there, if it will involve, okay, the least number of what unknowns possible. So if I take this, okay, I know my opposite, I know my adjacent. So I will go for the trig ratio that will involve least number of unknowns, and that will be the tan. Okay, if you go for cos, you have one unknown and one known. If you go for what do you call it, sine, okay, it will also involve one known and one unknown. But I can form a trig ratio that involve two knowns, and that will be tan because opposite adjacent. Oga Sanafa.
Yes, sir.
Okay, so tan is opposite of adjacent. So this means that my tan, so can I say that this implies that my tan, theta, will be equal to, this can be reduced. So I'm going to get 2 on 3, all correct?
Yes.
So let's label this as equation 1. Okay, then from the second triangle, which happens to be my first triangle there, right angle triangle, I've told you the order doesn't really matter. We could have done what we are coming to do first. Okay, so we'll get the same equations anyway. So from, right angle triangle ABC, okay, what do we have? We have, I'm going to form this particular triangle here, involve the side that I'm looking for, which is AB. So the ratio that I'm going to form must involve AB and maybe any other known, result. Because remember, you don't form a ratio, involving 2 unknowns. Other than your proportion that you form will be 2 unknowns. Okay, so form it inside that will involve only 1 unknown. So I'm looking for AB, which is the height of the tree. So in this particular triangle, any ratio that I'm going to pick or I will use should involve AB. All correct, my professors, so that I can find it. It should involve what I'm looking for. Point well made.
Well, please.
Did you say no?
Yes, please.
Oh, no problem. Okay, so don't worry at all. Let your no be strong, okay? Don't be scared of saying no. All right, okay, so that's your problem. All right, so now this is it. Okay, the question is asking you to find, you plan before you execute your plan. So here we know our plan. We've broken this one down. The question is asking us to form, find AB. AB is the height of the tree. Do you agree? Do you all agree?
Yes, please.
Yes.
Okay, so AB for us is the height of the tree after we introduced what our vertices. Okay, so now after that, what do? You now come, if you come to this particular triangle, okay, I can see that this right angle triangle involves what I'm looking for, which is the AB. Okay, so if I'm going to form a trig ratio, I will form a trig ratio that will involve AB. So that will involve opposite. This is opposite to my angle theta. So I'll form a trig ratio that involves opposite. And the trig ratio that will involve opposite will be tan and sine. Is that clear?
Yes.
You all agree, right? You're so catua. As for so catua, we are all experts. Otherwise, you have to go and revise. Okay, we cannot always go back. Okay, so in that case, okay, so opposite, I know the adjacent. Okay, I cannot form opposite over the hypotenuse. Other than that, the ratio that I'm going to form will involve 2 unknowns. I don't know the opposite, which is AB. I don't know AC. Okay, so if I take a ratio that will involve AC and AB, I don't know any of them. So how do I form an equation and solve for 2 unknowns? So take note of that. So that means that the ratio that I'm going to form should involve one known side and the side that I'm looking for, which is AB. Okay, so this side that I'm looking for, is the opposite to theta. So this is the opposite. Oh, okay, this side that I have here is adjacent. Okay, so which trig ratio involves opposite and adjacent?
Tangent.
Tangent, tan. Okay, Prof. Portia, okay, are you okay now? Portia and co.
Yes, sir.
Okay, so I can also say that tan of my angle theta, okay, will be equal to, in this case, my opposite is the length of AB. I hope you agree. Over my adjacent, and my adjacent is 30. Do you agree?
Yes.
Are you all with me?
Yes, please.
Okay, so, okay, I can call this equation 2. Okay, so you can see that tan theta is equal to 2 on 3. The same tan theta should give me the length of AB over 30. So I can say that if A is equal to B, that concept, okay, and the same A is equal to C, then I can say that B must be equal to C algebraically. Is that clear?
Yes.
Okay, so on that note, if I come and write equation 1, I know must be equal to equation 2. And this will always be too short to take a line. So comma, so it means 2 on 3, okay, should be equal to the length of AB, which is what I'm looking for, over 30. Do you all agree now? Okay, so tan theta is equal, the same tan theta is equal. So it means this must be equal to that. All correct. Hello, my profs, are you there?
Yes.
Okay,
Yes,
all right,
please.
all right. Okay, so on this note, this is what we are going to. Okay, so let me see. Okay, if I can. Okay, so on this note, we can all solve this. Okay, so we are going to get, this implies that I'm looking for AB, the length of AB. So the length of AB, I will cross multiply. So I indirectly in my mind, I've cross multiplied and I'm writing this side first. Okay, so that would be equal to, okay, 30, okay, times 2 on 3. Do you agree? My
Yes.
professor, do you all agree? Are you all with me?
Yes, sir.
Okay, so you know
Yes.
this can be reduced, or you can better still use your calculator. So that will give us which value?
20.
So this will go here 10, then so it will be 20. Okay. However, in drawing our conclusion, so here you know the unit, it will be meters. Remember, you cannot draw your conclusion with what you introduce. So the question asks us to find the height of the tree. So we are going to draw our conclusion. So therefore, 20 meters, write the math first, is equal to tree height. Someone can write the height of the tree is the same. Afa?
Yes, sir.
Yes, please. Yeah.
Yes, please. Any questions at this point?
Yes, please. Say,
Go ahead.
say please, did we equate the two equations because we used tan theta for both of them?
Yes. So if maybe you use sine and cos here, you cannot equate. Then it means you are supposed to go and find the theta value, okay, by saying inverse of theta will be the sine inverse of this, then maybe theta will be tan inverse before you equate. What you are equating, the quantity here and the quantity here before you equate must be the same. You get it? So always, if you use tan, this one will also be tan. If you use sine, this will be sine. So what you use for the first one, okay, will guide you as to what you are going to use for the second one as well. The trig ratio, in terms of the trig ratio. Afa?
Yes, please.
Okay.
Sir, please, I thought you have some equation which is C square is equal to B square A square plus B square. What about that one?
Okay, so you are talking about the Pythagoras theorem. Is that not it? You use Pythagoras theorem to find length. Okay, but if you can use Pythagoras theorem to find length, then you should know two of the lengths, and you have to use it to find an unknown length of a right angle triangle. Speedily, you can't use Pythagoras theorem for any other type of triangle other than, okay, a right angle triangle. So here, this one you can use, that's what I said. Okay, you can use Pythagoras theorem on this, but if you use Pythagoras theorem, you are going to find DC, which will not be useful. It won't help you in any way to find the length of what AB. You can't use Pythagoras theorem here because you don't know two of the side. So the only option left will be the trig ratio, because still we are dealing with a right angle triangle. You get it?
Yes, sir. Thank you.
You're welcome. Okay, so now what we have there will be the solution to exactly what is there. So we should be good to go. All right. So now, can we move on to the next question, my professors? Is this one well understood?
Yes, sir.
Okay, so now we are moving on to the next question. Okay, because we said so. So we are going to look at what? This one, okay, and maybe that will be our, let me check the next question, whether that will be your assignment. Oops, okay, so I think your assignment. I wanted to give this one to you rather as your assignment. And let me see if you'll be able to deal with it. Okay, so let me see the number of minutes left. Okay, should we do one more before your assignment, or I can still give this one to you as your assignment?
Let's do one more.
Okay, I saw it coming. All right, one is never enough. Okay, so let's see. As usual, solution. So let's picture what we have there. Okay, so quickly. Okay, so think through the question. I'm pausing the video. Okay, think through the question. Okay, then we'll come back and look at the situation altogether. Okay, so now that we've thought through, let's look at the situation again. A pole and a stick stand vertically on a level ground. Okay, the stick is 25 centimeters long and casts a shadow of length 20 centimeters. Okay, so let me finish, Frimpoma. I'll give you the opportunity to. If the pole casts a shadow of length 5 meters, what is the height of the pole? Okay, so here, if you look at what the information given, we know, okay, in terms of the pole, okay, we know its shadow, but we don't know its height. That is the length of its shadow, but we don't know the length of its height. But in terms of the stick, okay, we know its height and we know its shadow. So it means if you want to compare the length, okay, between the two verticals, the stick and the pole, we have to use the shadow, okay, the length of the shadow. So if you are looking at the length of the shadow, okay, what do you think, which one, in terms of which one will be longer and which one will be shorter? Okay, pole or stick? Somebody's hand was up before that. Hey, Prof. Impoma. Oh, you were done with the diagram and you were putting up your hand.
Yes, please.
Okay, all right. Okay, Prof. Frank.
Please, the pole will be longer.
The pole will be longer. Okay, why?
Because it's in meters. That's a higher unit than centimeters.
Okay, all right. Okay, so thank you very much. That is okay, a good answer. So please, the note in this question, okay, is what the different units. So before you deal with, okay, the diagram, make sure, okay, all your units are the same. Or before you deal with your units, work with the given units. Make sure all the units that you have there are the same. So this wasn't a typo error. It's not. Okay, it's intentional. So if you don't consider, if you centimeters, okay, meters. Oh, so it means, okay, the stick will be taller than what? The pole. Okay, that will obviously, okay, put you in a corner that will set you up to fail. So here, we know this is 500, okay, centimeters. And this is 20 centimeters. And between 500 and 20, obviously 500 is bigger. So it means the pole will be taller than what? The stick. All correct.
Yes, please.
Okay, so now we have analyzed the situation. We can go and put it, okay, in a pictorial form, in a diagram form. So let's go and quickly do that. So I have my two verticals. Okay, so I have my, okay, my ground. Oops. Okay, then my two verticals I have, okay, indirectly I have the pole. Okay, and I have, what do you call it, the stick. So maybe let me indicate the stick, okay, here. Okay, like I said, okay, the shadow, okay, the light source, okay, there will be a line here that will run from here up towards up to that, okay, and it will join. So this will also come and join. It will always be on top of what you have there. So vertical, horizontal ground 90, vertical, horizontal ground 90. So this again is your tree. And now this is your stick. All correct. Point well made, my professors.
Yes, sir.
Okay, so my stick, let me, all right. Okay, so now, okay, it's like the same picture that we are looking at. Okay, so if you look at the dimension, the stick we are told is 25 centimeters, okay, long. So this is 25. This length here is 25. This particular length is 25. That's your stick. And we know a shadow is 20. So I know the length here is 20. Okay, 20 cm. All correct. That is from here to here. Prof. Echo Jackson.
Sir, please, does it say a tree or?
Oh, sorry. Thank you very much. Okay, so it's supposed to be a pole. Okay, so thank you very much to be more precise. Okay, but when you are, this is just for the purposes of explanation. When you get it, you don't have to indicate that this is the stick, this is the pole, this is what have you. You get it. It's not necessary. Point well made. If you indicate, it will not, spoil anything. Only that if you do away with it, it can still save you time. Okay, and okay, you can use that time to do something else, however little. Okay, so thank you very much. We are dealing with a pole this time around. So pole, okay, to be more precise. So a pole, not a tree. Okay, so now this is what we have. The other distance that we have, okay, missing is for the 5 meters, and that is the shadow of the pole. So let me do this one well. Okay, so from here to here, okay, from here to here. So from here to here, okay, will be my, okay, 5 meters. Okay, so that will be 5 meters, which I know will be equal to what? 500 centimeters. All correct.
No, please.
Did I hear no?
Yes,
Please, my line was breaking, so I couldn't hear it well.
Okay, so when it comes to network issue, fortunately, I haven't gone too far. Okay, so as for the diagram, you know, I mean, our right angle triangles that we have there, you know, by the dimension to the, okay, so do you agree with the diagram, ignoring the dimensions for now?
Yeah, please.
Yes,
Do you all agree with the diagram?
No, sir.
Oh, how? But this is the same situation that we were looking at from the previous question 10. It's just the dimension that has changed and the naming. So this one, it's always be, whenever you are talking of what, two verticals casting a shadow situation. Okay, unless maybe they are opposite. Once they are on the same side, okay, you always have this picture. So draw your triangle, okay. For this will be the longer one and the shorter one will be inside. Then you use the shadow. The shadow always will be the ground. So this will be the shadow of what? The shorter one. The shadow of the longer one will run from here to here. As simple as that. If you know the height of any of them, then you indicate.
Okay.
Is it clear now, my professors?
Yes, please.
Okay, Prof. Portia, are you fine? Ignoring the dimensions, are you fine?
Yes, please.
Yes, sir.
Okay, so now we come to, you know, this is the pole. Originally, I wrote tree and I was corrected, or my attention was drawn to, okay, that's okay. So this is supposed to be stick. Okay, but you know, if you look at, so we are indicating the dimension that we know here after we've drawn our, okay, diagram that we have here. So we are told the stick is 25 centimeters long. So it means this stick from here to here will be 25. Do you agree?
Yes, please.
So you indicate 25 centimeters. Let me indicate the units. Okay. Then we said, and cast a shadow of length 20 centimeters. And remember I said the shadow, or just as I indicated here, the shadow of the stick will run from its base, that's the foot, okay, to the end of what your triangle that you have here, to this end. So it means from here to here will be 20 centimeters as indicated here. Is that clear?
Yes, please.
And again, we are told that if the pole casts a shadow of length 5 meters, and I said, okay, you cannot work with meters and centimeters, so you have to convert the meters, okay, to centimeters, rather than converting the centimeters to meters, okay, because we want to avoid decimals. Otherwise, someone can also convert, okay, centimeters towards meters. In that case, you will do the conversion twice. But if I convert, okay, meters to centimeters, I'll do the conversion once. Do you get it?
Yes, please.
It will be appropriate, apart from the fact that you want to avoid decimals, it will be appropriate for you to move from the meters towards centimeters, because your approximation equally will be done in the least number of times. You get it?
Yes, please.
Okay, so your shadow, the shadow of the pole will start from the foot of the pole, okay, to this particular end, just as we did previously. So it means the shadow will be from here up to here, but obviously I have to come down and indicate. Okay, so from here up to here will be 5 meters, which you know is equal to 500 centimeters. As for conversion, you did this in JHS, is that not it? So you should know that 5 meters is equal to 500 centimeters. Are you with me? 1 meter is equal to, is it not 100 centimeters?
Yeah.
So it means 5 meters will be 500 centimeters. So now all your dimensions will be in centimeters, then you work with it. Afa?
Yes, please.
Okay, so this is the figure, but I've told you, for you to make your presentation, your solution from the diagram, okay, coherent, flow, make sure you always indicate the vertices if the question didn't give you any vertices. So in this case, I am going to call this A, B, okay, C, the same way as I labeled the other one. Then this will be D, okay, and E. Yeah, all correct.
Same.
Yes, Victoria, you are fine, right?
Sir, please, I have a question.
Okay, so I also have an answer. I'm waiting for your question.
Sir, please, with the previous question, there was this expression that they cast the shadow at the same time, but over here, at the same time isn't here.
Oh, okay, all right. So usually, okay, so whether that is missing or not, okay, you know that the measurement is taken at the same time. I hope you are with me. So that's a good question. Okay, so whether we are silent on when it is what the measurements were taken or not, we are talking about what the measurements being taken at the same time. If they are taken at different times, okay, then obviously you know, okay, there will be variation in their dimensions or shadows, because you know, okay, it depends on how high, okay, or how bright, okay, your light source is, okay, and the length of the shadow. So if I take the length of my measurement for the stick in the morning and take the measurement for the pole in the evening or in the afternoon, obviously you know, okay, it will not be in sync. I'll be comparing oranges and apples. Do you get the point?
No, please.
Oh, so you know that the length of what, that's why we used to determine time. Okay, you know, in the olden days, we use shadow to determine the time. Okay, so how high the sun is will tell you, okay, the direction of your shadow and also the length of your shadow, where you are, the position. The position of the sun will tell you the direction of your shadow. The what do you call it? I should say how high, not high in terms of what do you call it, length, but high in terms of what? Its brightness. Okay, will tell you the length of the shadow. This is basic shadow situation. So if in the morning, stand, okay, and see the length of your shadow. In the afternoon, check the length of your shadow in the evening. So you know that you know that, okay, the brighter your light source, in this case your sun, okay, the longer your, what do you call it, your shadow.
Yes, please.
All other things being equal. You agree now, right?
Yes, please.
Okay, all right. So this is the situation at hand. And I said for convenience sake, we have to break it down. So we are going to break it down. Okay, and from there, maybe I should ask you to continue. Can I ask you to continue from here? Can't you continue from here? Or we should finish? Okay, are we in agreement that you continue from here or we should continue?
You will continue.
You will continue.
Yes, sir.
Okay, all right. Okay, Prof. Frank, your hand is up.
Sir, please, I have a question about the approximation. You said when we get the first value, it should be 4 dp.
Yes,
What if
anytime you approach. Sorry.
What if the last digit for the approximation is 0? Should we write it in 3 dp?
So you remember I said, okay, 3 dp or 4 dp, don't use 1 dp, don't use 2 dp. Okay, however, take it to 4 dp first. If it is 4 dp and you know that the other one is 0, okay, you want to ignore, you can ignore. But if you ignore, don't forget to put in bracket 3 dp. And because I want you to be consistent, okay, whether it is 0 or whatever number that you have there, take it to 4 dp so that it will always stick in your mind that 4 dp first before any convenient approximation or any required approximation. Is it clear, Prof. Frank?
Yes, sir.
Okay, Prof. Amy.
Sir, please, I wanted to ask a question.
Okay, go ahead.
Sir, is it possible to solve the question without a diagram?
Oh no, you always have to draw because we give marks for the diagram. So if you solve it without the diagram, fine, we can follow the logic in your presentation, but you will lose marks for the diagram. So we always encourage students when it comes to word problem and trig, okay, in this situation, students are encouraged to draw, to picture the situation before. So that's the more reason why marks are always given for the diagram.
Okay, thank you, sir.
Okay, you're welcome. Okay. Any other questions? Can we move on? I think let's finish it. Okay. My time is almost up. Okay, our time is almost up, but no worries. Okay, I will give you whatever you have there as your assignments rather. So I'll put it on the give you deadline. But now let's continue. So in the same way, dimension quickly. What do we have? Okay, the bigger one, we have the pole length we don't know. We know the length of the shadow, and that is 500. So we know this to be 500. Okay, then this is the only figure dimension that we can add here. With this one, we have 20. Okay, and we have 25 here. All correct. Hello, all correct?
Yes, please.
Okay, so in fact, I'm moved by my spirit strongly that I shouldn't continue from here because you can see that it's similar to what we did previously. Okay, or it's only the dimension that has changed.
Yes, sir.
You can see it's similar, only the dimension, changed. So you approach it in as much the same way, as we did there. So, for you to convince me that at least we're able to pick something from here, I will allow you. The greatest note or the strongest note is what? The diagram. Okay, from here, we should all be able to proceed. So what I will do is, please take notes. Okay, what I'm going to do is, you proceed. I'll put this one on the class page as your assignment. Okay, share with you as your assignment. Then, you start, it's your assignment, but you are going to start from the diagram. Okay, when you are drawing, please take notes. Don't draw in ink. Okay, unless maybe you don't have a pencil. Don't draw with your free hand. If you are sending, if it is your own, notebook, what have you, by any exercise, lines, avoid freehand lines. Circles, avoid freehand circles. Use the appropriate instruments. And don't draw in ink. Rather in pencil, so that if you get anything wrong, you can get it erased and correct it. Okay, so that will be it. And most likely, Okay, I think I can end the class so that the video will be short. Okay, I mean, then, okay, I will give you further instruction. So at this point, okay, this brings us to the end of today's lesson. Okay, thank you very much for sticking and staying with me, for your time, for making the class very interactive. May the good Lord continue to bless us all.